Students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as alkanes. Today we'll do the nomenclature of alkanes. What do you mean by nomenclature? The method of naming alkanes, right? Symbol or structure and the name. CH4, right? Now I'd explain this to you that guys in chemistry I'd explain this to you that one carbon atom is me, 2 is E, 3 is pro, 4 is but. This is one carbon atom, therefore this is going to be methane, right? Next CH3, CH3, 2 carbon atoms, therefore this is going to be ethane. CH3, CH2, CH3, 3 carbon atoms. 3 carbon atom is prop, so this is going to be propane. Fine. Next, CH3, CH2, CH2, CH3, 4 carbon atoms. 4 carbon atoms, that means this is going to be butane. Now comes the interesting part. CH3, CH, CH3, CH, CH3, CH3. Now, how many carbon atoms? There are 4 carbon atoms. Therefore, this is going to be butane. Right? Now, in this case, this is not in a straight chain. You have one of the carbon atom in a branch. Therefore, this is going to be called as isobutane. Right? Do we get this thing here? This is your common name for this. And if I'm doing IUPAC name, you have to consider the primary chain. Suppose if I'm doing IUPAC name for this is my primary chain. What is primary chain? The chain that contains maximum carbon atoms is called as the primary chain. So in that case, this is one which contains maximum carbon atom, 3 carbon atom, therefore this is propane. You have C, 1 carbon atom, that means methyl group, attached where? To the second carbon atom. So this is going to be 2-methyl propane. That would be the IUPAC name for this. Right? 3 carbon atoms in a straight line, therefore propane. Right? Methyl group is attached to the second carbon atom, therefore 2-methyl propane. Fine, do we get this thing here? Next, similarly if I have CH3, CH2, 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 CH3, 1, 2, 3, 4, 5 carbon atoms, therefore this is pentane. Right? Now, let's see some more naming. Okay. Now that we've done nomenclature, let's start with preparation. How do I prepare alkanes? Right? The first method for preparation, you have different methods for preparation. The first method for preparation of alkanes is decarboxylation of fatty acid. Decarboxylation of fatty acids. Right? Now, what do you mean by decarboxylation? As the name suggests, it's a reaction in which you remove a carbon from fatty acid. For example, what happens when, now you'll have to understand how to do the reaction. I'm going to explain to you how to do the reaction. What happens when sodium acetate is heated with soda lime? Sodium acetate with soda lime. Right? Sodium Na, acetate CH3COO. Right? Acetate group is CH3COO. So acetate is written as CH3COO. This is sodium and this is acetate. So this is sodium acetate. Right? Reacts with soda lime. Right? Now what is soda lime? Soda lime is nothing but a mixture of sodium hydroxide and calcium oxide. Right? So it reacts with sodium hydroxide and calcium oxide and is heated. Calcium oxide is used as a catalyst, right? In which case decarboxylation, that means D means remove, carbo means remove carbon, oxy means remove oxygen. So you have to remove carbon and oxygen. So if I remove carbon and oxygen, this sodium will combine with this sodium to give you Na2COOO, CO3. Sodium, this sodium combined with this sodium to give you Na2C123. 3 oxygens gone. That leaves you with one CH3 here and one H here. That leaves you with CH4. This is methane. Now guys, remember an important rule: whenever you are writing an equation in chemistry, always write the name below the compound that you are representing. Fine, do we get this in here? So sodium acetate reacts with sodium hydroxide to give you sodium carbonate and methane. Fine. Next, what happens when sodium propionate reacts with soda lime? Sodium propionate with soda lime, right? Sodium, Na. Propionate, that means how many carbon atoms should it have? 3 carbon atoms, right? Propionate, first of all, the structure should be this way. The final structure should be this way, out of which 1 carbon atom is here. I need 3 carbon atoms. So how many more carbon atoms I need? 2. This is going to be propionate. C2H5COO. Na, right? This is my sodium propionate. Reacts with sodium hydroxide, calcium oxide as the catalyst and is heated, right? You will have decarboxylation. Decarbo means remove carbon, remove oxygen. This sodium will combine with this sodium to give you Na2COOO, CO3. That leaves you with C2H5 here and an H here. So that leaves you with C2H6. C2H6, 2 carbon atoms, therefore this is going to be ethane. Right, do we get this? This method is called as decarboxylation of fatty acids. The second method for preparation is reduction of alkyl halides. Right? Let's see what happens when, I'm going to explain this to you with the help of reaction. What happens when methyl iodide is treated with zinc copper couple? Methyl iodide. Alkyl halide. Okay. Methyl iodide, alkyl, Yl. Methyl iodide is treated with zinc copper couple, right? Me, that means 1 carbon atom, right? Iodide, that means I. Now we know that the valency of carbon is 4, out of which 1 bond is formed here. So how many more bonds have to be formed? 3 more bonds. That's how the valency 4 will be satisfied. So this is methyl iodide reacts with zinc copper couple. Now when it reacts with zinc copper couple in the presence of alcohol, it gives rise to nascent hydrogen. When zinc and copper react in the presence of alcohol, it gives rise to nascent hydrogen, right? Now in this case you would have substitution reaction. How substitution reaction? You will require 2 atoms of nascent hydrogen. One of the atom of nascent hydrogen will combine with iodine to give you hydrogen iodide, and the other will substitute iodine to give you CH3, and that iodine is substituted by hydrogen. That means it will give you CH4, right? This is methyl iodide, and this is one carbon atom, therefore this is methane. So methyl iodide reacts with zinc copper couple to give you methane. Right, do we get this? Let's see another reaction of this kind. Ethyl bromide reacts with zinc copper couple. Ethyl bromide with zinc copper couple. Right, ethyl, 2 carbon atoms, bromide, Br. Now guys, put your bonds. This carbon has only one bond. The number of hydrogen atom is always 4 minus the number of bonds. It has only one bond, so 4 minus 1, 3. It will have 3 hydrogen atom. This carbon atom has 2 bonds. 4 minus 2, that means it will have 2 hydrogen atom. This is going to be ethyl bromide, reacts with zinc copper couple. In the presence of alcohol to give you nascent hydrogen. You will, for balancing, take 2. Out of the 2 atoms, 1 hydrogen will react with bromine to give you hydrogen bromide, and the other hydrogen will substitute this here. So in that case you will have CH3, CH2 was there. These 2 hydrogens will combine with 1 more hydrogen to give you CH3. This was ethyl bromide, and this is going to be ethane. Fine, do we get this in here? Next, this was the second method for preparation. First method is decarboxylation of fatty acids. Second method is reduction of alkyl halides. The third method for preparation of alkanes is called as Watt's reaction. Very, very important. A favorite with most of the professors. They generally ask you this in the paper. What is Watt's reaction? Now, Watt's reaction, in Watt's reaction you treat an alkyl halide with sodium or treat it with any active metal, you will get your alkane. For example, instead of theory, I'll show you the reaction. What happens when ethyl bromide is treated with sodium? Ethyl bromide with sodium. Ethyl, that means I should have 2 carbon atoms. Bromide, that means I should have bromine. Right? Ethyl means I should have 2 carbon atoms. Bromide means I should have bromine. Put your bonds. This carbon atom has only 1 bond. So number of hydrogen atoms will be 4 minus the number of bonds, so H3. This carbon atom has 2 bonds, therefore this will have 2 hydrogen atoms. Ethyl bromide reacts with sodium metal, right? I'm going to take 2 atoms of sodium metal, plus I'm writing the ethyl bromide again, but see how I'm writing it. I'm going to write this in reverse order. Bromine, CH2, CH3. I can write it anyhow. Reason why I wrote it this way, because I want to show you that this sodium is going to combine, the 2 atoms of sodium will combine with 2 atoms of bromine to form, this was ethyl bromide, to form sodium bromide, NaBr. 2 atoms of sodium will combine with 2 atoms of bromine to form sodium bromide. Whatever remains joins together. So you have CH3, CH2, and here again you have CH2, CH3. 4 carbon atoms, that means this is butane. 4 carbon atoms, therefore butane. Fine, do we understand this? So in Watt's reaction, you have, and you always have to, when you're doing Watt's reaction, you have to take catalyst as dry ether. The catalyst that is going to be used is dry ether. What happens in Watt's reaction? You get a higher alkane. Ethyl is being converted into butane. So you get a higher alkane by using Watt's reaction. Fine? Let's see one more reaction of Watt's reaction.
So what's a dry ether?
Dry ether, it's a chemical. Right? It's a chemical compound. Ether is a compound. Right?
So they will tell us in the body.
No, you will have this in paper. Explain Watt's reaction. Right? Now, what happens when methyl iodide reacts with zinc. Methyl iodide with zinc. Right? Methyl, that means one carbon atom. Iodide means I. This is methyl iodide reacts with zinc, reacts with methyl iodide. Remember, while doing Wall's reaction, take two atoms of or take two molecules of the organic compound. This is methyl iodide. Zinc reacts with this. Dry ether as your catalyst. Right? Iodine will react with zinc. Zinc valency is 2. So in that case, you will have zinc iodide. You have CH3 remaining from here, CH3 remaining from there. So CH3, CH3. This is ethane. Right? We get this thing here. So methyl iodide gives you ethane. Right? You will always get a higher alkane. The next method for preparation is hydrogenation. The fourth method for preparation is hydrogenation of unsaturated hydrocarbon. Unsaturated means double and triple bond, right? Now let's see this. What happens when ethene is mixed with hydrogen? Right? Ethene, 2 carbon atoms. E means 2 carbon atom. ENE, that means there has to be a double bond. ANE is single bond, ENE is double bond, YNE is triple bond, right? ENE, that means double bond. Now this carbon atom has 2 bonds, that means how many hydrogen atoms should it have? 2. This carbon atom has 2 bonds, therefore it should have 2 hydrogen atoms, right? Ethene reacts with hydrogen gas in the presence of finely divided nickel as catalyst. At 573 Kelvin. You have addition reaction taking place. What is addition reaction? When 2 or more reactants combine to give you a single product. Out of the 2 hydrogen, 1 hydrogen will combine here, 1 hydrogen will combine here. So this will become H3C, CH3. Double bond gets converted into single bond. So here, ethene gets converted into ethane. This is how you convert an alkene into an alkane, right? Hydrogenation enables you to convert an alkene into an alkane. Fine, do we get this in here? Let's see another reaction of this kind. What happens when propene reacts or mixed with hydrogen? Propene, 3 carbon atoms. ENE, that means I should have double bond. I could put double bond here or here, wherever I want. Let's assume I put it here. That means here I'll have to put single bond. This carbon has only 1 bond, therefore this will have 3 hydrogen atoms. 4 minus the number of bonds. This carbon has 1, 2, 3 bonds, therefore this will have only 1 hydrogen atom. This carbon has 2 bonds, therefore this will have 2 hydrogen atoms. Right? Reacts with hydrogen. You will have finely divided nickel as the catalyst at 573 Kelvin. Right? Now, in this case, you will have addition reaction taking place. Addition reaction will take place where the double bond is CH3C. One of the hydrogen will go here, so this will become CH2. The other hydrogen will go here, this will become CH3. Double bond will get converted into single bond. Right? This is going to give you 3 carbon atom, therefore propane. ANE because all single bonds. And this is propene. Right? Do we get this in
What's
here?
finely divided and
That's a catalyst. Ni. N1 no. Nickel. take powder nickel so that the reaction takes place faster. Nickel is used as a catalyst in this reaction so that the reaction gets over faster. Right? Let's see another reaction, guys. What happens when acetylene with hydrogen gas? Right? Acetylene is nothing but ethyne. The common name for ethyne is acetylene. Ethyne, that means 2 carbon atom. Ethyne, that means YNE. YNE, that means there should be a triple bond between carbon and carbon. If there is a triple bond here, that means this carbon has 3 bonds, it will take 1 hydrogen. This carbon has 3 bonds, this will take 1 hydrogen. Right? Reacts with hydrogen gas, you will still have nickel as catalyst at 573 Kelvin. Right? You would have addition reaction taking place. What is addition reaction? 2 or more reactants combine to give you a single product. Out of the 2 hydrogen, 1 hydrogen will go here, 1 hydrogen will go here. So this will become H2C, CH2. Triple bond will get converted into double bond. Right? So this was acetylene. That's my common name. The IUPAC name is ethyne. Okay? Gets converted into 2 carbon atom, therefore ETH, double bond, therefore ENE. Right? Do you understand this? This gets converted into ethyne. The ethyne so formed further reacts with hydrogen that is already present in the presence of nickel at 573 Kelvin. You will have another addition reaction taking place. 2 hydrogen, 1 hydrogen will go here, 1 will go here. So you will have H3C, CH3. 2 carbon atom, ETH, single bond, ANE, ethane. So an alkyne first gets converted into an alkene and then to an alkane. Fine, do we get this thing here by hydrogenation? You don't directly get an alkane, it will first get converted into an alkene and then it will get converted into an alkane. Fine, do we get this thing here? Let's see another reaction of this kind. What happens when propine with hydrogen? What happens when propine reacts with hydrogen? Propine, 3 carbon atom, YNE, that means I need to have the triple bond. Either I can put it here or here, wherever I want. Triple bond, 1 bond here. This will be H3 because the number of hydrogen atoms is 4 minus the number of bonds. This carbon has only 1 bond, therefore it will take 3 hydrogen. This carbon has 1 bond here and 3 bonds here, so it will not take a hydrogen at all. This carbon has 3 bonds, so it will take 1 hydrogen. Reacts with hydrogen gas. Nickel as the catalyst, 573 Kelvin. Right? Addition reaction. 1 hydrogen goes here, 1 hydrogen goes here. So this will be H3C, CH, double bond, CH2. Right? Out of the 2 hydrogen, 1 is going here, 1 is going here. This was propine. 3 carbon atom, therefore pro. Double bond, therefore ENE. So propine gets converted into propene. Right? Reacts with hydrogen gas again in the presence of nickel at 573 Kelvin. Right? That will give you H3C, CH, 1H from here will react here, CH2, CH3, double bond gets converted into single bond. 3 carbon atom, therefore pro, all single bonds, therefore ANE, propane. So propine gets converted into propene and propene then gets converted into propane. These are the different methods for preparation of alkane. Right? Next, this was preparation. Next, let's see the physical properties. What are the physical properties of alkane? Physical properties of alkane, they are colorless gas. They do not have any peculiar odor. So they are colorless. Second, they are insoluble in water. General characteristics of an organic compound: soluble in water. Right? Density. The density is less than that of water. the density of alkane is 0.8. Density of alkanes is 0.8 kg per meter cube, right? And the melting point and boiling point, they have a boiling point between 20 and 30 degrees centigrade, right? The boiling point and melting point and boiling point is between 20 and 30 degrees centigrade. Fine? Okay, so these are the physical properties. Let's come to chemical properties. Let's see the reactions of alkane. The first reaction that you have is called as halogenation. What do you understand by halogenation? Halogenation means reaction of alkane with halogen, right? For example, what happens when methane reacts with chlorine gas, right? What happens when methane reacts with chlorine gas? Methane, one carbon atom. So it will have 4 hydrogen atom. Methane reacts with chlorine gas. The reaction takes place in the presence of ultraviolet light, UV light. Okay. Now, you will have one of the hydrogen from here will react with chlorine to give you HCl. And one chlorine will go here. So it is going to be a substitution reaction, right? So you will have CH3Cl. Chlorine is going to go in and one hydrogen is going to come out. This was methane. This will give you one carbon atom, therefore chlorine, so methyl chloride. So methane, when reacts with chlorine, gets converted into methyl chloride, right? Do we understand this? So do we understand halogenation? In this, the reaction continues. The methyl chloride so formed will further react with chlorine to form dichloromethane, trichloromethane and tetrachloro. But the basic reaction is this. Methane reacts with chlorine to give you methyl chloride, and this reaction is called as halogenation. Fine, do we get the same here? The second reaction is called as nitration. What do we understand by nitration? Reacting with nitric acid. What happens when methane with nitric acid? Methane reacts with nitric acid. Methane, CH4. Methane, one carbon atom, so 4 hydrogen, reacts with nitric acid, HNO3. The reaction takes place at 673 Kelvin, and you are taking concentrated nitric acid, right? In this case, acid. What is the basic property of acid, guys? Basic property of acid is dehydration. It removes the water molecule. You are taking concentrated acid. First thing what will happen is the compound will lose a water molecule, right? Water molecule gone means one H is gone from here, one H is gone from here, and one O is gone from here. H2O, I need 2 hydrogens and 1 oxygen. One H is gone from here, that means that leaves me with CH3. This H is gone, N as it is. Out of 3 oxygen, 1 is gone, so NO2. Right? So methane reacts with nitric acid to give you nitromethane. Fine, do we get this thing here? NO2 nitro, CH3 methane, right? Or methyl nitrate. Either way, this is my IUPAC name. If I say common name, that will be methyl nitrate, right? Let's see another reaction of this kind. What happens when ethane reacts with nitric acid? Ethane, 2 carbon atoms. Draw the bond H3 and H3 so that the valency becomes 4. reacts with concentrated nitric acid, HNO3 concentrated, 673 Kelvin. Concentrated. First thing, dehydration will take place. You will lose a water molecule. The compound will lose a water molecule. One H gone from here, one H gone from here, one O gone from here. That leaves you with H3C, CH2. This H is gone, NO2. Right? So ethane will react with concentrated nitric acid to give you 2 carbon atoms, ethyl nitrate, or IUPAC name can also be said as nitroethane. Fine, do we get this thing clear? Next, propane with nitric acid. What happens when propane reacts with nitric acid? Propane, 3 carbon atoms. Right, draw your bonds. So this is going to be CH3, CH2, CH3. Right, reacts with HNO3 concentrated, 673 Kelvin. Right, now in that case you will have same thing that happens, dehydration, one hydrogen, one oxygen, right? In this case you will get water molecule first. Once water is out, what remains? CH3, CH2, C, NO2, CH3, CH2, CH2, NO2, right? Either I could call this as nitropropane or propyl nitrate. Either way, nitropropane would be the IUPAC name, propyl nitrate will be the common name. Right? So do we understand nitration? That was the second reaction. The third reaction that you have, first was halogenation, second is nitration. The third reaction that you have is called as pyrolysis. Right? What is pyrolysis? Pyrolysis refers to a method of thermal decomposition. If I heat any compound at very high temperature, the bond between them will break, and that process is called as pyrolysis. Right? For example, ethane is heated. What happens when ethane is heated? Ethane, 2 carbon atom, H3H3. If I heat it at very high temperature, suppose 873 Kelvin, right? If I heat this at very high temperature, the bond between carbon and hydrogen will break. If I heat it at very high temperature, the bond between carbon and hydrogen will break, and this will give me H2, right? That will leave me with CH2, CH2. To balance this, there has to be a double bond. So this is ethane, 2 carbon atom, ETH, double bond, ethene. In this case, an alkane is getting converted into an alkene. This is exact opposite of hydrogenation. In hydrogenation, alkene got converted into alkane. In pyrolysis, alkane gets converted into an alkene. Fine, do we get this thing here? Now similarly, let's see one more reaction of this kind. What happens when propane is heated? Propane heated. Right? If I heat propane means 3 carbon atom, right? Draw your bonds, H3, H2, H3 is heated. You heat it to 873 Kelvin. When you heat it to 873 Kelvin, due to intense heat, the bond between carbon and hydrogen breaks. One hydrogen molecule is liberated. Right? Let's assume for that hydrogen molecule, one hydrogen came from here, one hydrogen came from here. So that will give you CH3, CH, CH2 double bond. So this will give you propane and this is propene. 3 carbon atom, therefore prop, and double bond, therefore ene. Fine, do we get this thing here? Now, this kind of pyrolysis is called as dehydrogenation. In this, what am I doing? I am removing hydrogen atom, right? So when you have pyrolysis, you can have pyrolysis by means of dehydrogenation, or you could also have pyrolysis by means of a rupture. In the case of that, you would have, say, suppose if I have propane, suppose if I heat propane for 873 CH3 CH2 CH3, I'm going to heat it at 873 Kelvin. Another method would be where you will get CH4, methane gas out, C, 2 hydrogens from here and 2 hydrogens from here, right? That would leave me with 2 hydrogens, so 1 from here and 1 from here. That would leave me with CH2, this is totally gone, CH2 double bond. Either way, it would end up giving me an alkene only, right? This is propane and this is ethene, 2 carbon atom, therefore ETH double bond, and methane. This method of pyrolysis is called as cracking. So there are 2 methods of pyrolysis. Either I can have dehydrogenation or I can have cracking. In dehydrogenation, hydrogen molecule comes out. In cracking, you will have both organic compounds coming out, right? Next, the 4th reaction that you have is combustion. What do you mean by combustion? Combustion means burning in air. When any organic compound, basic law, when any organic compound is burnt in air, what will you get? Carbon dioxide, water and heat. When any organic compound is burnt in air, you will always get carbon dioxide, water and heat. So suppose if I give you a reaction that methane is burnt in air. Methane burnt in air. Methane, CH4, burnt in air. Oxygen, right? Methane is burnt in air. What will you get? You will get, when any organic compound is burnt in air, you get carbon dioxide, water and heat. Large amount of heat energy is released, right? So let's balance the reaction, guys. You have H4 here, you have H2 here, right? So H is balanced, oxygen becomes 2 and 2, 4. So your oxygen is also balanced, right? Carbon is already balanced. So in this case, you will get the amount of heat energy that you get in this reaction is about minus 890.4 kilojoules per mole. That is the amount of heat energy that is liberated, right? So when methane is burnt in air, you get carbon dioxide, water and heat, right? Similarly, if I give you any compound burnt in air, it should give you the same answer, carbon dioxide, water and heat. The only thing is that you should know how to balance it, fine? Instead of methane, had I given you, say, ethane. Suppose if I give you ethane is burnt in air. If ethane is burnt in air, ethane is C2H6 burnt in air. Any compound, organic compound burnt in air should give you carbon dioxide and water. Now the only question is, how do I balance this, right? I have 2 carbon, for which I am going to put 2 here. I have 6 hydrogen, right? So 3 here. So in that case, oxygen becomes 4 and oxygen becomes 4 and 3, 7. So I cannot get 7 here. So in that case, what I'm going to do is I'll make this as 7. So in that case, now my oxygen is 14. Double the whole process. I had 7. 7 was an odd number. You can never balance with an odd number. To convert it into even number, you double the whole process, 4 and 6. Right? So in that case, now carbon becomes 4. So I made carbon as 4. Hydrogen becomes 12. Hydrogen is 12. And 4 to the 8 and 6, 14. All of them are balanced. Right? Do we get this thing here? So do we understand combustion? In combustion, you could also have incomplete combustion. Suppose if I had incomplete combustion. This is when the compound is totally burnt in air. Suppose if if methane is burnt in insufficient supply of air. Methane in insufficient supply of air. Methane in insufficient supply of air. Methane, CH4. Oxygen, right? Insufficient supply of air. Whenever you have insufficient supply of air, you get carbon monoxide and water. So in that case, you will get carbon monoxide and water, right? Balance the equation. Hydrogen is 4, right? Oxygen is 3. I just told you if you get an odd number, write that number here and double the whole thing up. So this will become 2 and this will become 4. So my oxygen gets balanced, 6 and 6. Carbon becomes 2. Put this here. So this is also balanced. Carbon is balanced with 2. Hydrogen is balanced with 8 and oxygen is balanced with 6. Fine, do you get this in here? So these were all the chemical reactions. Uses. The last thing that you have in this chapter is uses. Where do we use alkanes? Right? Methane is used as a source of ammonia. Propane is used as a refrigerant in your refrigerator. The gas that cools your refrigerator is propane. Right? Butane and isobutane are combined together to form LPG. Right? Then they are also used to make paraffin wax. So these are some of the uses that you have of alkanes. With this chapter is over. We'll stop this here for the day. Thank you very much.